Welcome to part 31 of our series on building a Zelda-like game in Phaser 3. In this video, we'll bring our dungeon to life by creating our pots, chests, and enemies using our data from Tiled. This will allow us to dynamically spawn interactable objects and enemies based on our level design. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and set up our level items. Now that we've built our dungeon level, it's time to bring it to life by adding interactive objects. Using the data from our tiled map, we'll dynamically create important elements like pots, chests, doors, and even enemies. This will allow us to define our level layouts visually in Tiled, while keeping our game code flexible and scalable. Let's dive in and start placing objects into our world. So previously in our game scene, we added in logic to parse our object layers from Tiled, and we created a bunch of methods as placeholders for creating our various game object types. We're going to now focus on adding in our logic to actually create our game objects from that tiled object data. So similar to what we did for our create doors method, we're going to take our tiled objects, we're going to iterate through them, and then create instances of the game object that's tied to it. And so we're going to start off with our pots. And so for our pot class, we need to grab all of our valid tiled objects, and now we want to iterate through them. So I'm going to copy this logic here. Let's come down here. We'll get rid of our console log. Let's get rid of our to-do and our console log here. And now instead of creating a door, we want to create a pot game object. Now we'll do an instance of our pot. And currently our pot class is set up, so we pass in a config object, which will have our scene and our position. We want to change this to follow the pattern that we started in our door class, where we have our phaser scene, and then our config is going to point to our tiled object for that game object. So if we jump over to our pot class, let's make that change. So for our constructor, first we'll do our phaser scene. So for our type, we'll have phaser scene. Now for our config, instead of pot config, we're going to do our tiled pot object. Let's get rid of our pot config type here. So we'll get rid of this line of code here, and now we'll have our scene, and now we want to do our config.x, and then our config.y, and then keep track of our position. We'll do the same change there. So now we made that change here, let's come back to our game scene. Now when we create our pot instance, we want to pass in our instance of our scene, our tiled object. But now when we store our reference to our pot, we want to do this on our pots array, and we'll push in our pot instance. So after we add that to our array, we want to add that to our blocking group, so we'll collide with that game object. So we'll do this, we'll do our blocking group, let's do add, we'll add in our pot game object. Now we'll get rid of these two lines of code here. Alright, so let's go into our temporary code. Let's comment out our code here, where we create our pot instance and we add it to our pot game objects array. And then let's comment out our code here, where we create our blocking group, and we add our chess game objects to that. So now with that change, now we need to create our blocking group when we set up our level. So let's go to our create level method. We'll come down to where we create our door transition group. I'm just going to copy that line of code, we'll paste it, and now we're just going to do our blocking group. Now if we save and we come back to our game, we should see right away that two new pot game objects have been added to room 3 in our dungeon. So now our player should be able to go ahead and collide with those game objects, and now if we come up to room 2, we should see that our pot game objects have spawned in this room as well. Now that we have our logic in place for creating our pot game objects from our data in Tiled, before we move on to our other game objects, I want to go ahead and clean up our temporary code that we initially added where we created our various enemies, our chess game objects, and our pots. Instead, we're going to rely on our data from Tiled to create those objects. And so as part of that cleanup, we'll need to refactor our collision logic to no longer rely on those groups and use the groups from our objects by our room ID object. So to clean up this code, let's go into our temp code method. Let's remove that whole block of code here. Next, we'll want to remove our two properties that were tied to that temporary code. Our first will be our enemy group. And so our enemy group, that's going to be stored down here on our objects by room ID, where we have our room ID and our object here. We'll do the same thing for our pot game objects array here, since that data will be stored down here as well. So now down in our create method, let's get rid of our to-do here and our temp code call. Now down in our register colliders, now we want to get rid of our references to that temporary code. Alright, so for our method here, to get started with our refactor, first let's bring up our code where we check for our player's collision between our player and our collision layer. So we'll grab this logic here, we'll bring that to the top of our method. So next for our player, let's grab our overlap check between our player and our door transition group. We'll bring that to the top of our method, and then we'll grab our logic for our collider between our player and our blocking group. So now for the rest of our collision logic, we now need to iterate through our objects by room ID object, and for each of our rooms, we want to grab that enemy group and create a collider to add in those collision checks. To get started with this change, we'll just do our object, let's do our keys, let's do this, our objects by room ID, and now for each of our keys, as now for each of those keys, we'll get a reference to our room IDs. We'll do const, let's do our room ID, we'll set it equal to parse int, and we'll do our key. So once we have our room ID, we just want to make sure that exists on our object. So we're just going to add a safeguard. So we're going to do if this, our objects by room ID, if that room ID is undefined, we'll return, then we'll return early. And so then if it's not undefined, now we want to see if that room has a group of enemies that we need to have collisions with. We're going to do if this, our objects by room ID, and our enemy group. So if our enemy group does not equal undefined, and so now if our enemy group does exist, now we want to add in our colliders and our overlap checks between that enemy group and all the logic that we did here. To start with, let's grab our logic where we add in our collision check between our enemy group and our collision layer. So we'll grab this logic here. So we'll come back to our if statement, let's paste our code in here. Instead of doing this .enemy group, we want to grab a reference to our enemy group here. So we'll copy and paste that in. One other change we'll do is we're going to remove this logic here where we set our collision. We only need to do that one time for our collision layer. So we're going to bring that up here to the top of our class. Let's paste that in here. Now if we come back down to our code, next we'll want to add in our collision check between our player and that enemy group. So let's copy this logic here. We'll come back up here. Let's paste that in. So now for our check, we'll grab a reference to our enemy group. Next, we'll remove our logic where we register our collisions between our enemies and our world bounds. Now that we have our collision layer in place, we shouldn't need that logic. Finally, we'll want to add in our collider between our enemies and our various blocking game objects. So let's copy this code here. We'll come back up to our if statement. We'll paste that in. So now we just want to update our reference to our enemy group. So we'll copy this. Let's paste that in down here. Alright, so that should take care of our logic for our enemy group. Now we need to handle our pot game objects for that particular room. For this, let's copy our code here. Let's drag that up below our if statement. And now we're just going to modify our safeguard here. So instead of doing this, our pot game objects, we want to reference this, our objects by room ID, our room ID. And then we'll want to check for our pots array on that room. So now we'll just update our references. So instead of doing this, our pot game objects, we'll paste that here. We'll keep our blocking group. Alright, so now if we save, and when our browser refreshes, our player should still be able to collide with our collision layer that we set up, and our player should be able to collide with our pot game objects just like before. Once we get to the part where we add in our logic for our enemies, we'll verify that our collision logic for our enemies and our player is still working properly. And so now one last change we're going to add for our collision logic is for our pot game objects, we want to make sure these game objects actually collide with our collision layer. So right now our player is able to actually throw our pot outside of our dungeon room, and instead once it hits our wall here, we want our pot to break. And so to add in that check, let's copy our logic here where we have our collider between our pots array and our blocking group. And now we just want to update our reference to be this and then our collision layer. So now if we save, we should be able to come back to our game. If we grab one of our pots, if we move our player over by our wall and we throw it, our pot should break right away once it collides with that layer. Next for our level objects, we'll focus on dynamically creating our chess game objects from our data and tiled. For this, we'll need to enhance our chess class to have some new properties to match some of the properties from our tile map data. And we'll want to update our configuration to be more in line with what we did for our pot game object, where we just pass in our tiled object that represents our chest, and then we'll grab our properties from there. To start making our changes, let's go into our chest class. Let's get rid of our chest config type here. So now in our constructor, first let's add in our phaser scene. So for our type, we'll have phaser, we'll have scene. Now we want to do our config. This is going to be our tiled, our chest object. Now we want to pass in our chest state. And so we're going to make this optional, and we'll do our chest state, and we'll do hidden. Alright, now for our code updates, let's get rid of our first line of code, where we destructure our scene and our position. Now when we call super, we want to reference our config. We'll grab our x and y values from there. It's now for our chest state, we'll want to grab that from our constructor, and so we'll just set this equal to chest state. Next, we'll need to add a few new properties to our class to match our data from tiled. This will be things like our chest ID, what our chest contents are, and what the reveal trigger is if it's a trap type chest. So at the top of our class, we'll add an ID first. So we'll make this a number for our type. Now we'll do our reveal trigger. For our type, this will be our trap type. Now we want to do our contents, and this will be our chest and our reward. So now down in our constructor, we'll want to initialize these properties. So we'll do our ID is going to be equal to our config, our ID. Our reveal trigger is going to be equal to our config, our reveal chest trigger, and now our contents will be equal to our config, and then our contents. Now that we've added our new properties to our class, let's add in some getters so we can easily retrieve those properties. So after our constructor, we'll do get, we'll do our reveal trigger. This will return our trap type. So we'll do return this, our reveal trigger. Let's copy that block of code. We're going to do two more getters. We'll want to do our chest ID. So our type will be our number. Let's return our ID. Now we want to do the contents on our chest. Now this will be our chest reward. And we'll return this and then our contents. Next, for our chest class, we want to have the ability to enable and disable our game objects based on our room our player is entering or leaving. And so this will be similar to what we did for our pot game object class, where we have that class implement our custom game object, and then we add in our enable and our disable object methods. So to do that, let's come over to our chest class. After we extend our phaser physics arcade image, let's do implements, and now we'll do our custom, game object interface, and now we need to add in our two methods. So if we go into our pot class, let's copy our two methods from there. We'll come to the bottom of our chest game object, let's paste those in. Then for our disable object method, we don't need to make any changes, but for our enable object method, we'll want to check our chest state. So if our chest is actually hidden, we don't need to enable our physics body or make our game object visible until we want to reveal it. So we just need to add in a safeguard to if our state is equal to our chest state, and if it's hidden, then we can just return early. Now that we have our two methods, the last change we need to make for our chest class is we just need to add some logic tied to our chest state. Currently for our chest game object can be in one of three states. It can be hidden, revealed, or opened. By default, when we create our game object, we're setting our chest state to be hidden. So when we created our chest game objects in tiled, we set up our chest game objects to have a trap type, and we set it to either be none, enemies defeated, or switch. So now when we create our chest game objects, we want to check our trap type. If our trap type is set to none, that means our chest should be visible to our player at all times, and if our trap type is one of the other two, it needs to be hidden by default until the player meets that condition to reveal our chest. To layer in this logic, we'll start in our constructor, and so we want to update our default chest state if our trap type is none. So at the bottom of our constructor, after we add in our components, we'll do if, we'll do this, if our reveal trigger is equal to our trap type.none, and now we'll want to check our chest state, and so if it's hidden by default, now we want to make it revealed. So we're going to do if, we'll do our state is equal to our chest state dot hidden. Now we'll update our state, so we'll do this, we'll do our state, and we'll say equal to chest state revealed. Now that we've updated our chest state, we'll want to either show or hide our game object based on our reveal trigger. So when we create an instance of our chest, if our trap type is set to none, then we want to update our state to have it be revealed, and we'll want to have our game object visible to our player when they enter into our room. If our chest is tied to one of our two trap types, we don't want it to be visible to the player until they meet those conditions. To add in that change, inside our if statement here, we're just going to add in a return statement. And now if our chest is either tied to our enemies being defeated or stepping on a button, we'll want to disable our game object. Finally, for our chest class, we just need to add in one more public method, and this is tied to revealing our chest to our player. So as an example, when our player is in one of our rooms, if there's a hidden chest and our player presses a button to reveal that chest, we'll need to have a method that will update our chest state and then enable that game object in our scene. That way our player will be able to collide with it and interact with it. So for that change, let's come down to the bottom of our chest class. We'll add in a public method. We're going to call this reveal. We won't return anything from this method. First, we're going to check our chest state. And if our chest state is not hidden, we'll return early. So I'm going to copy this block of code here from enable object. We'll just change this to not. Now, if our chest state is hidden, now we want to update our state. So we'll do this. Our state will be equal to chest state, and we want to reveal our chest. And now we want to enable our object. So now that we have our reveal method, after our player reveals our chest, they should be able to interact with it, and they should be able to open it up using our open method on our class. Now that we finished updating our chest class, let's jump back over to our game scene, and in our create chest method, now we need to create our chest game objects from our tiled objects. For this, let's go into our create pots method. I'm going to copy our block of code here where we iterate through our tiled objects and we create our pots. Let's paste that in our create chest method. Let's get rid of our to-do and our console log. So now when we're iterating through our tiled objects, let's update our variable name. We'll change this to be chest. We'll update our class name, so we'll do chest. We'll pass in this for our scene, our tiled object. So after we create our game object, we'll want to add that to our chest array for our objects by room ID. We'll pass in the instance of our chest. We'll also want to add this to our chest map. So I'm going to copy this line of code. Let's paste it. So now we'll do our chest map. On our map, we want to use our chest ID for our key. Instead of calling push, we just want to set it equal to our chest game object. And then we'll want to add this object to our blocking group. So now if we want to test our changes, come back over to our browser. We'll have our player navigate to our next dungeon room. We shouldn't see any chests by default in this room, since our current chest should be hidden by default. If we move over one more room, we should have one chest that's visible and one that's hidden. And now if we come to our last room, we should see our boss chest is now visible to our player. And then finally, if we want to test being able to reveal one of our chests, let's come down to the bottom of our class. When we have our tween for after our player enters into one of our rooms, we're just going to add in code to manually reveal one of our chests. So once we finish updating our player, we're going to do this. Let's do our objects by room ID. We're going to get a reference to our current room. Let's grab our chest map. We're going to grab our first chest, and we're going to call reveal. So now this is going to simulate that our player revealed the chest in our first room. And so now when we enter our room, our chest game object should now appear to our player. And if we come up to it, our player should be able to open our chest, and we should see our console log line of chest being opened. Alright, so now that we've tested our change, let's remove that line of code, and we'll save. Now that we've finished dynamically creating our chest, it's time to move on to our enemies. Let's jump over to our game scene. Let's find our create enemies method. In our method, let's clean up our to-do and our two console log statements. Now we'll want to iterate through our array of our tiled objects, so let's do for. We'll do const tiled object of our valid tiled objects. And now for each of our objects, we'll want to check our type property on our enemy object, and depending on that type value, we'll create our different enemy types. So first we'll add a safeguard to make sure it's one of our known types. So we'll do if our tiled object.type does not equal 1, and if our type doesn't equal 2 or 3. So let's just copy this here. We'll paste it. So we'll do 2, and if it doesn't equal 3, then it's a type we're not aware of in our code. So we're just going to do continue to move to our next iteration of our loop. And as long as it's one of those values, we can create our various enemy types. So we'll start off with type 1. So this will be our spider. So we'll do if our tiled object type is equal to 1. Now we want to create our spider. So we'll do const spider will be equal to a new spider instance. Now for our configuration, we want to pass in scene. So we'll pass in this. Now for our position, and now on our position, we'll have our X. This will be our tiled object, our X property, and we'll do the same thing for Y. And after we create our spider enemy, we want to add this to our enemy group for our existing room. So we'll do this. We'll do our objects by room ID. We'll do our room ID that we passed in. Now we want to reference our enemy group. Now we want to do add, and we want to do our spider. So then after we create our enemy, we can continue to our next iteration on our loop. Now we'll want to do the same thing for our other enemy types. So let's just copy this here. We're going to paste it. If we have type 2, that's going to be our wisp. And we'll just update our variable name. And we'll paste our code one more time. So let's copy this here. And so if our type is 3, this is going to be our boss enemy. And for the time being, we're just going to add it to do. And we'll have our continue to go to our next iteration. So we'll do to do. We'll say create boss enemy. So one last change we need to make to our code is we need to make sure our enemy group is actually defined, so we're adding our game object to the correct group. By default, our group is optional since not all of our rooms will have enemies in our game. And so to add that check, we'll come outside our for loop, And so we're just going to do if our objects by room ID, if our current room ID that we provided, if that enemy group is undefined, now we want to create that enemy group. So we're going to do this, our objects by room ID, the room ID, we'll reference our enemy group property, and we'll set that equal to this.add.group. Pass an empty array for our children. Now for configuration, we want to do run child update. We want to set that to be true. So now down in our for loop, we can remove our optional chain since our game object group will exist. So now if we save, let's come back to our browser. We should be able to test. Let's move up one room. We should see our 2 spider enemies and our wisp enemies being created. If we go up to our boss room, there should be no enemy since we're not handling that type. Now if we refresh, let's go to the right, and we should see our 2 wisp enemies. If we go over one more room, we should have no enemies. And then for our final room, we should have our 2 wisp and our 4 spiders. So we have 1, 2, 3, 4. Nice. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.